Hello guys, today we will continue and actually finish with the series of equations that you are supposed to be using for linear kinematics. Just to make a very quick recapitulation, let's remember that we have so far four different equations that you can work with. One is the definition of acceleration, change in velocity divided by the time interval. The other one is the concept of average velocity, displacement over time, or the average of the initial and final velocities. The third one that we just discovered in the first video here was a relationship between displacement, initial velocity, time interval, and acceleration. So as I told you before, the idea is that you use this when you don't know and don't want to know the final velocity. There is a sister equation for this, which is the one that has final velocity time minus 1/2 acceleration time squared. And so we could number these equations just as a mnemonic help. This is equation 1, this is equation 2, this is equation 3, and this is equation 4. And the whole idea is that you can identify them by what's missing in each of these equations. In the first equation, we will have no displacement present. In the second one, you have no acceleration present. In the third one, no final velocity. And in the last one, no initial velocity. And now we move on to the fifth and last of these equations. What if you didn't have any time interval? How could you find an equation for that? The technique is basically the same one as the other two. You start out with the two basic equations and you want to combine them in such a way that you can get rid of the time. So, for the first one, obviously time is equal to final velocity minus initial velocity over acceleration. The second one is a little trickier because if you multiply times 2 and you multiply times the time, then you have this parenthesis that you need to move as a block, all of it. So the time is actually equal to 2 times the displacement divided by initial velocity plus final velocity, and that is also equal to final velocity minus initial velocity over acceleration. Taking these two things together, getting rid of the time, you can do a little more algebra. You can take final minus initial velocities times, and I'm going to switch around this addition, which is possible because this looks very nicely as the product of a sum and a difference. And on the other side, you can multiply times the acceleration. It's customary to write this in alphabetical order, so twice the acceleration times the displacement. This that you have here is called the difference of squares, and so you have final velocity squared minus initial velocity squared is equal to twice the acceleration times the displacement. In literature, Usually you find the final velocity alone and the initial velocity on the other side. And sometimes you express this as a difference between final and initial position, but I would rather have it like that. And so this can be numbered as equation number 5. That is the last one of them, and it deserves a little red rectangle. So that is the last equation that we want to discover. 5 variables, 5 equations. Each of those equations has 4 elements, and on the next video we'll find out how to use them in a productive way. So that's it for today. Thank you very much.